Welcome. Let's see techniques for reducing the grounding resistance of a substation. By reducing the grounding resistance of a grounding system, reduce the maximum ground potential rise, and it will also reduce the maximum transfer potential. Several techniques have been applied to reduce the grounding resistance of a grounding system. Systematic techniques include 1. Increasing the grounding grid. 2. Connecting the main grounding grid to an extra external grounding grid. 3. Increasing the burial depth of the grounding grid. 4. Utilizing natural grounding bodies such as the steel foundations of structures. 5. Increasing long vertical grounding electrodes and 6. Replacing the soils around the grounding grid for low resistivity materials. These techniques are suitable for different geographical locations, but that does not mean they should be taken up independently. In fact, in a specific soil environment, 2 or more techniques should be taken up to reduce the grounding resistance effectively. Adding deep vertical ground rods to the grounding grid is very effective, especially in urban substations with only a small area. This method can utilize the low resistivity soil layer and remove seasonal influences. In order to reduce the grounding resistance, a unique method was proposed for decreasing the grounding resistance of grounding grids in a high resistivity area, called the explosive grounding technique. This method has been proven very effective, and the only deficiency of the explosive grounding technique is the high engineering cost. We will discuss simple methods for reducing grounding resistance one by one. Let's see technique 1.1. Expanding the grounding grid area of a substation. Substation grounding resistance can be calculated by below equation, as per IEEE 80. From above equation, we can see that the grounding resistance is inversely proportional to the square root of the area. The greater the area is, the lower is the grounding resistance. Definitely expanding the area of the substation grounding grid is an effective method to decrease the grounding resistance. The method of increasing the grid area, in order to reduce the grounding resistance, can only be used in specific regions. For substations in mountain areas, it is not possible to expand the grid area. For substations in urban districts, it is impossible to find suitable land to expand the grounding grid area. Let's see technique 1.2. Connecting with an external grounding. Connecting with an external grounding is a method which involves connecting the main grounding grid of a substation with an auxiliary grounding grid, which is laid in a low soil resistivity region outside the substation in order to reduce the grounding resistance of the whole grounding system. It should be noted that there is a significant potential difference between the substation grid and the auxiliary grounding grid in a fault condition. When a high-frequency impulse, such as lightning, acts on the system, the potential difference will be especially important. So it should be ensured that there are several grounding conductors in parallel connecting the main grounding grid with the auxiliary grounding grid. Let's see technique 1.3. Increasing the burial depth of the grounding grid. From above equation, we can see that increasing the burial depth of a grounding grid will decrease the grounding resistance if other parameters remain unchanged. But the effect of this method is not noticeable, specifically in a high soil resistivity area. Therefore, an engineering project generally does not adopt this method. The burial depth of a substation grounding grid is generally about 0.6 meter. Let's see technique 1.4. Using natural groundings. Natural groundings contain the steel reinforced concrete frames of buildings, hydropower intake trash racks, gates, water pipes, etc. These natural groundings, because they themselves have a low grounding resistance, should be connected with the main grounding grid, in order to achieve the purpose of reducing the grounding resistance. Especially in a hydropower substation, using natural groundings can reduce the grounding resistance effectively without increasing the investment. Let's see technique 1.5. Partially changing the soil. Soil resistivity directly affects grounding resistance. For some grounding devices that locate in a high soil resistivity area, if it is difficult to use other methods to decrease the grounding resistance, the method of partially changing the soil can be used. We can use a low resistivity soil, or low resistivity material, to replace the original high resistivity soil, around the grounding device. Soil resistivity directly affects grounding resistance. For some grounding devices that locate in a high soil resistivity area, if it is difficult to use other methods to decrease the grounding resistance, the method of partially changing the soil can be used. We can use a low resistivity soil, or low resistivity material, to replace the original high resistivity soil around the grounding device. We will see below techniques one by one. Using long vertical ground rods to decrease grounding resistance. Explosion grounding technique. Deep ground well. Slanting grounding electrode. Stay tuned, we will discuss these in upcoming videos. Thank you for your attention and time. More stuff coming soon. Don't forget to subscribe.